Hi guys, this is Nick, the Safety Director for the MECO group. This is going to be your crane signaling and rigging training. This is designed to be refresher training for those of you who've had it before. This is the same presentation you would receive if this is your new employee orientation or if I was giving this in person. At any point during the training you can pause the video, you can call or text or email me with questions, so please feel free to do so. With that, we're going to get started. The purpose of this training, like I said, is going to be either initial or more likely refresher training to everyone that's involved with crane lift operations, helicopter lifts, rigging activities, and that includes almost all of us, whether it be the sheet metal trades, the pipe fitters, the electricians, the runners. Everyone's involved in the crane lift process, and everyone needs to be trained in this. Gone are the days where we send someone out to a crane pit and here you go, learn. That's not really effective. This training also is going to designate a competent person in accordance with OSHA and ANSI standards. And if you remember correctly, a competent person is someone who has the knowledge and skills to recognize hazards of that particular task and also has the authority to do something about them. So someone who can stop a crane pick, someone who can say, yes, this is good rigging. Not everyone's going to be the competent person on the crane lift, and that's okay. Competent has nothing to do with your intelligence. It's a designation that we put on you as a foreman or as a very skilled employee. I had to give you training that's one of the accordance of both these standards, and I have to give you training who would be affected. So not only is it going to be the signal person, it's not going to be the qualified rigger. Everyone who's involved in the process has to have the same training, and all this training is regulated by the following standards. And the cranes are kind of different in the sense that they're not just in one standard of OSHA. They're kind of bounced around between the 1926 550 or the 1400 subpart CC or the 1910 179 through 184, and this training is designed to encompass all of those points brought up in all three of those sections. I need to give you guys this training before you're going out to your first crane pick, and sometimes that doesn't always happen, and sometimes you come from another company who does crane picks. It doesn't have the same training, but I want to give everyone at least the same base foundation. If there's ever a change in your duties, so many times a runner's not going to be the one on the roof giving signals. He's typically going to be on the ground giving assistance in rigging, or he might be the chief rigger. But if he progresses in the company and goes on to be a foreman, he's going to be one giving the signals. So again, he'd probably need some refresher training. If there's ever a change in crane lift operations that present a hazard about an employee who has not previously been trained, if there's changes in the standards, if there's changes in the lift plan, which we often create before the lift happens, and we do a brief before the lift, but if something changes and we're not trained for that, we want to take a time out and take a look and maybe give some refresher training. If there's ever reason to believe that maybe there are deviations from the training you've received, if you're not doing them correctly, or if maybe you've forgotten, we want to make sure that we're giving you some retraining, not as a punishment, but to get you back on track. This training, again, is not to be the end-all. This is continuous improvement. You should be watching this video several times to refresh yourself. Remember the signals, remember the practices that we put in place. So what we're going to talk about today, we're going to go over some definitions, just some quick definitions of what terminology we use during crane picks, the different duties depending on who you are. We're going to go over rigging, we're going to go over signaling. There's going to be a special couple slides on helicopter lift safety. We don't do it very often, but it's a lot of moving parts and something that deserves its own couple of slides. And then we're going to go over some general crane safety. So let's go over some definitions. What is a crane? It's not just the crawler crane or the big 200-ton semi-truck looking crane. A crane, by definition, is a machine for lifting and lowering a load and moving it horizontally, with the hoisting mechanism as an integral part of the machine. The load is not just the rooftop unit we're lifting or the exhaust fan. It's everything that's putting weights on that hoisting mechanism. That's going to be your rooftop unit, your block and tackle, your rigging apparatus. All that's going to count as the load towards the rated load, or the load at which your crane or individual hoist mechanism is designed and has a capacity to lift. Also known as the working load limit, we're going to talk about in the next couple slides. But again, it involves everything that the crane is lifting, and the crane operator has to take that into account when he's doing critical lifts. We can calculate working load limit. I don't ask you guys to do too much math, and very rarely do we have to calculate working load limit on the site or at the time of the lift. The management and the supervisors work very hard behind the scenes to make sure this is done for you guys, so that at the time of the lift we're not grabbing a calculator and a pen and paper trying to calculate working load limit. But we can if something changes. Just remember that we typically know the weight of the unit before we do this. We know the distance it has to go, and a lot of the heavier units have pick points, and it has things for us to use as kind of cheats. So we don't have to do this math, but we can if we need to. The equation itself is the vertical working load limit, and multiplied by the number of legs, multiplied by the sling angle factor. And we need to know the specific angle of our rigging apparatus before we can do this equation. And we have some factors. These are constants. These are never going to change. So we can look these up if we needed to. When we're using a 4-point sling attachment, we're going to use 3 as a number of legs instead of 4. And the reason being is it's difficult to really get equal load on all 4 legs. Sometimes those rooftop units have the compressors on one side. That's going to put more load on the left or right side than it would the other. So it's very hard to get equality. So our vertical working load limit is going to be the weight, or our total weight that we talked about in the previous slide, which is the rooftop unit, which is 500 pounds. Multiplied by 3, we're using 4-point sling attachment, and our sling angle factor at 60 degrees is 0.866. So our working load limit is 1,299 pounds. That is what the pressure is going to be, and obviously our rigging apparatus has to be rated for. Many times I've seen we go overkill on our rigging, and that's perfectly okay with me, as I'm sure it's okay with you guys, for using a 5,000 pound sling for 1,200 pounds. So that's just kind of calculating a working load limit. Again, we don't do it very often, but we have the ability to if you want to. So let's go over some duties. First and foremost, the duties of the employer. We are just as involved as you guys in the crane process. We're calculating the load limits. We're calculating the load plans. We're also in charge of hiring decent crane companies. We're not trying to hire some backyard crane service that's not going to be able to conduct our lifts, that's not certified by the states. It's our job to make sure we're giving you the best we can. It's also our job to make sure that you're given the training that you deserve, that you need, and it's our job to make sure everything goes smoothly. You as the employee. As the employee, you know what you're supposed to do. You know the way around the shop, and you know what you're supposed to do on the field. But when it comes to training, it's on you to make sure you're receiving the appropriate training. If you're not getting good training, let someone know so we can change our training so we can get you to the training that you need. It's also your job to understand. If you're not understanding what we're saying, it's not going to be effective training, and we're setting you up for failure. And that's not what we want to do. The kind of flip side to that, if you're an employee, you're not involved with the crane pick, leave the area. The more people in the area, the more difficult the crane pick becomes, the more moving parts, the more we have to look out for. The duties of the operator. The operator is typically a union member who's certified by the state to operate that equipment. He's trained. He's the competent person. He has the license. When he's on site, he is now the foreman. That is his job site. He is in charge of that lift evolution. They have the final say whether a lift is safe, if the rigging is good enough. And what he says goes. It's not our place to argue with the crane operator whether to do a lift or not. At the end of the day, it's his crane, it's his lift, and we don't want to see what happens if we go outside of what he's comfortable with. Qualified person. This is a lot of words, and you can pause this video if you want, but OSHA uses qualified as a word 3 times in OSHA, one of them being in cranes. The qualified person is kind of like the competent person, where they have the training, they have the knowledge, they have the authority, but the qualified person has the formal degree, has the state certificate, has the license. That's a qualified person. Our crane operators are going to be a qualified person. And we'd be doing you an injustice if the person was not qualified. So that's kind of the duties. What we're going to talk about now is rigging. And the rigging is probably one of the more important parts of this entire evolution. I'm going to warn you guys, the rigging section of this is kind of repetitive. It's a lot, in fact, it's mostly the inspection process, and I'll explain why. When it comes to rigging, we want to make sure we're using good and serviceable rigging. Once it leaves the ground, it is out of our hands. If something fails in that rigging because it's defective or broken or worn, there's nothing we can do about it, and we're going to lose the load. So we want to make sure we're set up for success by using good rigging, and the best way you can do that is to inspect the rigging prior to use. There's different styles of rigging, and we're going to use each one depending on the shape, size, weight of the material we're lifting. There's vertical, there's choker, there's multi-leg, and there's other methods we can use, and sometimes we have to get creative. It'd be super helpful if all of our rigging apparatus had the different load limits, because each rigging style has a different load limit. For instance, if you see at the bottom picture, if you have it in a basket method, your load limit's 12,800 pounds. It's almost cut in half by a vertical rigging attachment, and it's even less for choking it. So we want to keep that in mind for rigging. The different styles have different limits. Like this table shows right here, each rigging style, each shackle size, all this comes into play with load limits. And again, for the most part, we try to go above and beyond. We don't want to take that too close to the edge. Remember, you can pause this video at any time to study these if you'd like. So we're going to get into rigging equipment, and we can use a vast array of rigging equipment depending on our load, our conditions, our crane style. But what we're going to talk about is our wire rope slings, our synthetic web slings. Those are kind of the two main rigging apparatuses we use. We're going to talk about shackles, chains. We can also use chain falls and hooks. But all these are available to us, and that's going to depend on what we want to use them for. Again, the inspection process is the most important part of this, and keep in mind we have to do this every time. So for wire rope slings or steel braided cables, when we're inspecting them, we want to check for corrosion, kinking, bent hooks, broken wires, and even heat damage. All of these can ruin the integrity of the rigging apparatus, and ruin integrity means it's going to hold less weights. And unfortunately, I can't tell you what that would mean. I can't tell you, oh, it's 2 broken wires, your capacity is down by 2,000 pounds. When you talk about corrosion, it's not just rust. Corrosion comes in many forms. Different metal contact, pitting. But in this case and in this instance, it's mostly the oxidation of the iron, and that's when you get rust. Things are going to rust. It happens. They're exposed to the atmosphere. But too much rust, like you see in these pictures, degrades the integrity of the rigging. And I can't tell you how much degradation equals how much capacity is lost. So I don't want to leave that to chance. If it looks too rusty, it's too rusty. And bring it up to the attention of the operator. Kinking, bird caging, distortion, any type of damage to the steel cable is going to, again, it's going to affect the capacity. Kinks, knots, unraveling, any deformations are going to lessen the capacity. We want to make sure we're keeping an eye out for those. Broken wires. Broken wires we typically find with the palms of our hand. It usually hurts pretty good. If there's broken strands, there is a length it can have. So for every 8 diameters, if there's more than 10% of the broken strands, we're not to use it. General rule of thumb is if it's got some broken strands, bring it up to the operator. The operator is going to know whether that's serviceable or not. We don't want to leave it to chance. This is also why we wear gloves in the field. Heat damage. I've never seen heat damage on a steel cable, but it's part of my presentation. I want to go over just in case. Again, heat damage is going to cause the steel to be brittle and to be worn excessively and lose integrity. So we want to make sure we're inspecting our wire ropes from top to bottom, end to end, to make sure these are good cables that we're using. Because again, if it snaps, we're going to lose the load. If a steel cable snaps, it could have a whip effect, and we don't want that to damage our equipments, and more importantly, we don't want to get hurt ourselves. If we see any of those issues, if there's cut strands, if there's bird caging, if there's heat damage, bring it up to the attention of the operator and let him decide to take it out of service or not. Chances are we might have to find different rigging material. Next, we're going to talk about synthetic web slings. We use these a lot. They're lighter, they're easier to handle. They're just as strong, but they do come with their own kind of issues. They're easy to get burnt, get tears and cuts. They become brittle as they get older, and their stitching can get torn. They're prone to a lot of these. So we want to make sure we're checking our synthetic web slings just like we would our steel cables. We have tears and cuts. Caustic burns or acid damage is going to cause, again, to lose integrity. As you can see on the right, as they get worn up against things, they kind of get worn down. A lot of them have special stitching that if they get stretched beyond limitation, you'll see some red thread. And if you see red thread, it's out of service. I want to make sure they're not tied in knots. If it's tied in a knot like you see on the left, the capacity is taken down by 66% or about 2/3. If it's tied in a knot on the right, run away because it's going to fail right away. We also need to inspect our chains, our steel alloy chains, for corrosion, elongation of the links, any damage. Chains are also supposed to have a tag on them that says the type of alloys, the type of metals, the capacity. I know many times that tag is the first thing that we lose, but it's supposed to be there. So we're checking our chains for damage and corrosion. These are kind of the pictures of what we're looking for. We can see elongated links, broken links. You see that tag that's supposed to be on every chain. These are some wrong methods of utilizing a chain. Chain that's not going to perform how you think it's going to. When we're using shackles, shackles can get damaged too. We want to make sure we're checking our shackles for corrosion, damage. Make sure we're checking the pin, the threads. Look at the capacity. All the shackles should have a rated capacity. We want to make sure we're using the correct tool for the job. We're also inspecting our hooks and any other connecting devices. Anything we're using, our rigging is a system. And if any part of the system is damaged or not going to work, our system is going to fail. So make sure we're checking everything we're using. A lot of times when we use shackles, they're in some funky places, some different angles. Here's how to correctly use a shackle. We want to use the strongest parts of the shackle, which are shown in green, and the weak parts are shown in red. We don't want to use red. Red is dead. So if we're not using our shackle correctly, we're setting ourselves up for failure. Make sure you use the correct size shackle, that we're not bunching up the synthetic web sling. Make sure we're... here's a hint. When you're tightening shackles, make sure you tighten the screw all the way and back it off a quarter turn. When they put pressure on the load and everything kind of seizes up, it will be almost impossible for the next person to get that pin undone once there's pressure on it. So that's kind of the inspection process of a lot of the rigging material that we're going to use. Remember, inspect all of it before use every time. Some lifting methods we use a lot are the engineered pick points, which could be the lifting eyes, the lugs, or there's specially designed pieces of that equipment that are designed to be used with shackles or lifting apparatus. A lot of our heavier stuff, our bigger equipment's going to have this stuff engineered into it. Some of the smaller things, the weirdly shaped things, I know with exhaust fans we typically choke those, which is direct to the equipment. And then the basket or cradle method if the equipment's on a pallet. These are in order of stability. So a basket or cradle method is the least stable, and we try not to use it unless we have to. So just some safe work practices when utilizing rigging or round crane picks. Never stick your hands or arms or anything any extremities between the slings of the equipment when tension's being applied. When that crane starts to lift, a lot of pressure is going to be put on those slings, and it could crush you or trap you. Again, always inspect your slings and hooks and everything else prior to use. That's the most important part, because if we're not using good rigging, once it's up in the air, it's out of our hands. We can't do anything about it. Take any of that out of service and bring it up to the attention of the operator. I know it goes without saying, but we don't want to exceed the lifting capacity for a rigging equipment or a crane that's asking for trouble. We don't want to stand underneath the suspended load. Accidents happen. If the rigging were to fail and that were to crash down on top of us, we want to be as far away from as possible. I know it gets a little difficult when we're using a tagline, so just be smart. Once it gets up in the air and your tagline gets short enough, let go and get out from underneath the suspended load. This is what happens if your rigging fails. We don't want this to happen. And that's what happens when your rigging fails. So that's it for rigging. Again, the most important part is the inspection process and utilizing good and serviceable rigging. Next section, we're going to talk about signaling. We're going to talk about all the signals you see here, what they mean, what they do, and then go over some safe work practices. Use the main hoist. This is typically used when you have multiple cranes, a primary and a secondary crane, if the crane has multiple hoist mechanisms, we're going to top a tap of our hard hat. This is signaling to that crane operator, to the primary crane operator, hey, I'm talking to you, please follow my signals. And he's going to follow your signals until you give him another signal. The whip line, or the secondary hoist, you're going to tap the bottom of your elbow. Again, you're going to tell the secondary crane operator, hey, I'm talking to you, follow my next signal. Hoist, or cable up, winch up, depending on the configuration of the crane, using one finger, your pointer finger, make a circular motion up, and this is going to be cable up. This is going to tell the crane operator to load vertically using this cable or winch. Likewise, if you want him to lower, winch down, cable down, using that same finger but having it in a downward position, making a circular motion, that's going to tell him to cable down or winch down. Raise boom. Giving him the thumbs up, that's going to tell him to raise boom. That's going to not only lift the unit vertically, but also going to move it horizontally as well. It can be seen as, hey, you're good, so try to avoid using the thumbs up sign unless you're telling him to raise boom. There are other methods to tell him that the load is clear, so just be mindful. Again, lower boom is going to be the thumb down position. It's going to lower the unit or material down vertically, but also going to move it fore and aft horizontally. If you wanted to do both at the same time, you can combine these two, tell them to either boom up, cable down, and likewise boom down, cable up, by giving them both signs, whether a thumb up or thumb down, and a pointer finger in a circular direction, either up or down, depending on what you want him to do. If you want to tell the operator to swing a certain direction, you're going to take your arm with your palm facing flat and down and your arm straight. You're going to tell him to swing that direction. The crane operator should have the swing path already in mind, but if you need to make minor corrections or adjustments, you can tell him to swing one way or the other using your hand face down, arm flat. If you need to tell the operator to extend a boom, this is more prevalent in a lull or a Class 7 off-road forklift apparatus. But if you need to extend boom, you're going to take both hands with the thumbs pointing outward. You're going to move your fist away from each other. He's going to extend his boom until you tell him to stop. Likewise, if you want to retract boom, you're going to turn your thumbs facing inward and move toward each other. For whatever reason, and I don't recommend this, but if you're holding the tagline and need to tell the operator to extend boom, you can do it. Please pay special attention. This wasn't intuitive to me. I would have thought it would have been different, but this is the signal that's shown here. So as you're holding the tagline, you want to extend boom. Point your thumb to your chest, and this is going to tell the operator to extend his boom. Again, I don't recommend it. I would hope you have enough manpower that someone else can hold the tagline, but you can if you need to. Conversely, if you need to retract boom, point away from your chest while holding the tagline. If you want the operator to move slowly, he should already be moving slow, but if you're near the drop zone, or if you need to tell him to move slower already is, you can tell him to move slower by placing your palm over your hoist signal, and that's going to tell him to raise it or lower it slowly. If you need to tell the operator to stop, you can extend an arm out, almost like the swing path signal, but bring it in, so bend it in towards your chest. A more universal sign would be a closed fist raised in the air. That's a more recognized stop symbol. And the operator is going to know, he can tell the difference. Emergency stop. So if something's about to happen or already happened, use your emergency stop signal by using both palms, make a stop signal. So it almost looks like you're marshaling an aircraft, but rapidly move your arms in and out to tell him, stop right now. If we're using crawler cranes or trains on tracks, we can tell them to move if we need them to. If we want to travel one track, which is going to make them turn, with the stop signal with one hand, our other hand is going to make a travel motion as indicated in the picture. That's going to front or back. It's going to tell that operator which track you want it to move in which direction. If we want to travel both tracks, which will be forward and back, using both arms, we're going to make a travel motion. Dog everything is not something we use. It's typically reserved for the iron workers or the guys setting beams. But this is kind of a pause button. Clasping our hands together in front of our chest. That's a pause button to have them stop temporarily so the iron worker can set his rivets or do what he needs to do and then move on to the next beam. We're not going to use this, but it's still a signal that's out there and we want to make you aware of it. So that's it. That's our main signals. Many cranes have them posted on their cranes in case we forget. Crane signals aren't meant for us to get creative and cute and kind of make up our own. We want to make sure that we're using recognized signals and that everyone's going to understand. So some safe work practices when we're giving signals. We want to make sure we're maintaining visibility with the crane operator when giving hand signals. If he can't see you, he's going to stop until he can see you again. Give hand signals that are easy to see. Try not to hold your hands in front of the body unless you have to. And if you can see by the picture, this guy's giving crane signals in front of a white building wearing white gloves. It's very difficult to see his hands. And again, as a crane operator, I would think that they would stop, but I would hate for them to try to guess at what you're trying to tell them to do. If you can't give hand signals or visibility can't be established, there are other methods of communication, and actually they're more preferred over hand signals. Radios and hard lines are more preferred depending on the contractor. If a person is far away, so if the pick is 150 feet in, you might have to use a middle person to relay those signals. And the crane operator knows there's probably going to be a delay, so it's going to be moving slow. Again, if you're near a roof edge, you need to be protected against falls, so have a harness and lanyard or a parapet or some other method of fall protection when you're giving signals on a roof edge. So that's kind of our signals. We're going to talk about helicopter lift safety. Again, we don't do it very often. However, when we do, there are a lot of extra steps and precautions. So we're going to talk briefly about helicopter lift safety. Helicopter lifts are awesome. They're fun to watch. They're fast and efficient. They can reach perimeters beyond the practical reach of normal cranes. However, there's a lot more hazards with them, and we'll kind of go into that next couple slides. Because they're so specialized, we're going to use helicopters and crews that do only that. We're not going to hire some random pilot. We're going to make sure it's a helicopter lift company. There's a lot of moving parts and things that need to be planned out and discussed between the controlling parties. There's a lot of things to consider: load limits, fuel, structures, weather. All of these are going to affect our helicopter lift. You want to take those into consideration. They're going to have their own crew. Typically, it's going to be one, maybe two pilots, depending on the type and size and style of helicopter. They'll have their own mechanics, load masters. They'll probably have their own signalers and riggers. So if we're involved in this crane pick and helicopter pick and they have their own crew, get out of the way. But if we are involved, you follow the directions of the pilots who's going to be in charge of that operation. Pilots have a lot to consider. They have to carefully balance fuel and weight with the desired load. The more fuel they're carrying, the less capacity they have. Just for fun, 1 gallon of JP8 or jet fuel or aviation fuel weighs about 6.66 pounds. So the more fuel we're carrying, the less we can carry. Rotor wash causes brownouts and dusty conditions. That's going to greatly reduce visibility, so we want to make sure they're not hovering very long or as little as possible. Much like ground cranes, the person in charge is going to be the pilot or the controlling entity. They are the foreman, they're the boss, what they say go. The pilot's going to be receiving direction from the signal person, who's going to be in clear view. That's probably not going to be us, but if it is, we're going to be trained on those signals because they're going to be different. Remember, when it came to hover time as short as possible, not just because of the rotor wash, the downforce that's being created, and the longer that pilot stays static or in one position, there's a lot of things that can go wrong. Helicopters are very noisy, so we want to make sure all wearing ear protection that's rated for such. And because they're so noisy, communication is going to be very difficult, especially with the guys set in the unit. So make sure we're keeping good communication, making eye contact, and acknowledging signals. As always, before any crane pick, we do a pre-lift briefing, but we're going to make sure we're doing a very detailed briefing with the helicopter crew. Some helicopter lift safety. Because of all the moving parts and the way the helicopters are designed to fly, they build up a lot of static electricity. What they suggest is that we slap the load with our hand to discharge static electricity, because if we go up and touch it and keep our hand there, all that static is going to go into our bodies. And if in theory, if we slap it and remove our hand right away, it's going to discharge electricity safely. With helicopters, we want to use a tagline. Because of the nature of the way the helicopters move, they cannot control the material as well. And beware of ground hazards when lowering loads. We're going to make sure that there's nothing on the roof we can trip on, because it's going to be very windy up there. It's going to blow us around. Make sure there's no trip hazards or holes in the roof, ground wires. So we have to be very aware of our surroundings when helicopter lifts are going on. This is just a video of a helicopter I thought was cool. You could see that the unit or Humvee was grounded before it was being lifted. You could see the rigging apparatus and the signal person. These guys were talking over ICS or radios as their signals. So that's it for helicopter lift safely. Again, we don't do it very often, but when we do, it's very important that we follow the right precautions. So we're going to talk about some general crane safety. A lot of factors to consider when doing crane lifts. They're affected by weather, high winds, lightning. We want to make sure we're using our outriggers. We set up on a stable, even surface. We got to make sure we're away from power lines, and if we are near power lines, how to safely maneuver around them and do lifts around them. We want to make sure that our swing path is away. We want to make sure when we're lifting over buildings that the people in the building, if there are people in the building, that they're aware of the crane pick and that they're evacuated from the area during the operation. We never want to get between the swing path and the object. If something were to fail, you don't have anywhere to go. And as always, wear the appropriate PPE. What that means is hard hats, safety glasses, safety shoes and boots. I suggest we wear high-vis vests or high-vis clothing when we do. It's not a rule, but it makes sense to me that if we're wearing high-vis clothing, the operator and other people involved in the lift can see us and therefore react safely. Again, cranes are affected by weather, winds, lightning, um, rain. All this can affect the operator's ability to move a load and to see if there's lightning in the ground in the area. He's not going to do the lift. He's a very high conductive material. Sometimes in open ground, that's a recipe for disaster. We want to make sure we set up in a stable, level surface. Even if they've done it 100 times, their crane operator needs to use outriggers. It needs to set up in a stable surface. And here's why. What we see is a bridge being put in South America on the edge of a riverbank, and the operator, as you can see later, has outriggers. He's got the big weight pads, but it's not a stable surface, and you'll see that the bank is starting to fall away. So even using your outriggers and your pads is not enough. You need to set up in a stable surface, and this is not a stable enough surface. Keeping away from overhead power lines. If a crane was to come in contact with energized lines, electricity is going to flow through that crane and into the ground, and what we'll see in the video is it's going to find its way home. We've all been in this situation. We get in a rush, we're in a hurry, we're frustrated. This is a drywall style crane where the operator is controlling from a remote control. I don't know what he was thinking, but as he swings, he's going to come in contact with the power lines. I'm not sure why he's going that way. As you saw in the video, he was told to stay put unless he was in immediate danger. The reason being is the electricity is flowing in a circular pattern, almost like ripples on a pond, trying to find its way home to a ground, to the next power line, and it's going out in rings. You can't see the rings, but if we were to move and we move in the wrong direction or we move in an unsafe manner, we're going to get shocked and electrocuted. You kind of saw him shuffle. And what we don't want to do is have one foot in one ring and one in the other. The electricity would travel up our leg and out the other leg, and that's when you get the damage. There's different ways of moving safely around electricity, but more importantly, I'd like you to not come in contact with electricity in the first place. Every crane class I've ever been to, ever taken part of, has had this video. This is the Big Blue crane accidents that happened in the Miller Park, 1999, where some precautions weren't taken. It was a very windy day. The operator was told, the first operator said he wasn't going to do it, so they got someone else to do it. And as a result, a couple of iron workers died, and it was a really gnarly accident. So that concludes our online training for crane settling rigging. Thank you for your time and paying attention. When you finish, please email me with your time and date of completion, and in the subject or in the body, please send me the word oranges. I know it sounds silly, but this is going to let me know you've watched the video in its entirety. Depending on who you are and where you work for, send it to the appropriate address, whether it be DeKalb, Miller's, or Lesher's. Again, thank you for your time, and be safe.